Okay, so now we're going to talk about dimensional analysis. The process of converting from one unit to another is called dimensional analysis or unit analysis. To convert units, multiply by one or more ratios of equal quantities called conversion factors. For example, to convert inches to feet, you would use the ratio below as a conversion factor. 1 feet to 12 inches. There's 12 inches in a foot, so that is going to be our conversion factor if we were changing inches to feet. Now, caution. Be sure to put the units you are converting to in the numerator and the units you are converting from in the denominator. So, here's the example. Finding conversion factors. Find the appropriate factor for each conversion. Feet to yards. There are 3 feet in 1 yard. To convert feet to yards, multiply the number of feet by 1 yard there's 3 feet in 1 yard, so 1 yard to 3 feet. Remember, back here we said make sure that you put the units you are converting to in the numerator and the units you are converting from in the denominator. So we were going from feet to yards, so feet went in the denominator, yards went in the numerator. To over from. You can think of it that way. Pounds to ounces. We're going from pounds to ounces. To over from. There are 16 ounces in a pound. To convert pounds to ounces, multiply the number of pounds by 16 ounces to 1 pound. So, you try it. Find the appropriate factor for each conversion. A, minutes to seconds. Remember, you're going from minutes to seconds, and you're going to do 2 over from. Press pause and try. Okay. There are 60 seconds in 1 minute. To convert minutes to seconds, multiply the number of minutes by, what are we going to? Seconds. So that's on top, 60 seconds. What are we converting from? Minutes. So that goes on bottom. So try B, hours to days. You're converting from hours to days. 2 over from. Press pause. Okay, there are 24 hours in 1 day. To convert hours to days, multiply the number of hours by, remember we're converting 2 days, so that's on top, 1 day to 24 hours. Hours is on bottom because that's from what we're converting from. Days is on top because that's what we're converting to. 2 goes on top, from goes on bottom. Okay, finding conversion factors, which we just did, and using conversion factors is a little different. So let's practice using conversion factors. The average American uses 580 pounds of paper per year. Find the number of pounds of paper the average American uses per month to the nearest tenth. So first we need to know that the problem gives the ratio 580 pounds to 1 year and asks for an answer in pounds per month. The goal here is to set up 2 proportions to where whenever you go to multiply, you're able to cancel out units. Because what you want is 2 units. You want 1 ratio, 1 unit to another. So you need to cancel out what you don't need. What we don't need is years. We want months. So here we have set up the ratios 580 pounds per year times 1 year, and this 12 should be down here. 1 year to 12 months. That it goes against the 2 over from grain, but whenever we use them, the goal is to cancel them out. So that's why they differ in finding and using differ. So now that we have we have multiplied the ratio by the conversion factor, what's nice about this is you can cancel out your year unit. So if you look over here, there's an example. Pounds over years times years over months. This cancels out and this cancels out, and pounds becomes over months. So now you have 580 pounds over 12 months. And if you think about it, this completely makes sense. Because if there's 580 pounds in a year, there's 580 pounds in 12 months. Because there's 12 months in a year. Then it looks like a division problem, doesn't it? So if you need to break it down to unit rate, where you break it down to 1 month, you just divide by 12. Top in, bottom out will give you 48 3/10 pounds per month. So the average American uses 48 3/10 pounds of paper per month. So you try. Sam drives his car 23,000 miles per year. Find the number of miles he drives per month to the nearest mile. The problem gives the ratio 23,000 miles to 1 year and asks for an answer in miles per month. So go ahead and pause the video and give this one a try. Okay, let's check it out. So when we set this up, hopefully you set it up 23,000 miles in a year, because it's 23,000 miles per year. And we need to find the number of miles in a month. Remember, you need to cancel out what you don't need. We don't want the years. We want the months. So we set it up to where we have our year down here, and we have a year up here, because then they cancel out. And you can just move miles over months. So there's 23,000 miles in 12 months. Now we're going to divide by 12. That way we can break it down to our unit rate per month. When you divide it out, it's 1916 repeating per month. But the answer needed to be in the nearest mile. So we round that. Circle what you're rounding, point to what's useful. 5 or more, raise the score. 1,917 miles per month. That's how much Sam drives his car. Okay, so we're going to do a problem-solving application with this. Here's the question. A car traveled 60 miles on a road in 2 hours. How many feet per second was the car traveling? This one's a little different because you're having to convert more than one thing. We're going miles to feet and hours to seconds, if you notice. I'm going to take you through this problem-solving application step by step. First, you need to understand the problem. The problem is stated in units of miles and hours. The question asks for the answer in the units of feet and seconds. You will need to use several conversion factors. So miles to feet, hours to seconds. So we're going to list the important information first. Feet to miles. On your formula chart, you have this information. There's 5,280 feet in a mile. Hours to minutes. 1 hour is 60 minutes. Minutes to seconds. 1 minute is 60 seconds. All that information is found on your formula chart. You don't even need to memorize it. You just write it down on your test booklet, your paper, your worksheet, whatever it is you're using. So we got to make a plan. You got to have a plan to get to the solution. You're going to multiply each conversion factor separately. So yes, it is going to take a while. Yes, you are going to have a lot of work on your paper. So first, third, you're going to solve. Reduce my ratio to a unit rate if possible. So we had 60 miles in 2 hours. In order to break that down to a unit rate, you had to divide by 2 to get 30 miles in 1 hour. Now I'm going to convert those miles to feet. So you remember all this information back here that we listed? I'm just going to go in order. Feet to miles, and then hours to minutes, and then minutes to seconds. I've already written out everything I'm going to use. So in order to convert miles to feet, I set up my ratios. 30 miles to 1 hour times the conversion factor, which we wrote down back here. Conversion factor, 5,280 feet in 1 mile. Remember, you want to set it up in a way that you have something to cross out. So that way you're left with only 2 units, feet and hours. So there are 158,400 feet in 1 hour. So now miles is gone. We've got the first part down. Now I'm going to convert my hours to minutes. So I set up my ratio, 158,400 feet in an hour. I multiply by my conversion factor for hours to minutes, 1 hour and 60 minutes. I'm able to cross out the hours, thank goodness, because I only want feet to minutes right now. And I end up with 158,400 feet in 60 minutes. Please remember, whenever you multiply straight across. If you forget that part, you're going to be lost. Fourth, convert your minutes to seconds. So I take my ratio and I set it right here. I'm going to multiply by my conversion factor, which is 1 minute and 60 seconds. I'm able to cross out the minutes and then multiply straight across. I end up with 158,400 feet, and then 60 times 60 was 3,600 seconds. Now let's find that unit rate. You are able to divide 158,400 by 3,600, and that breaks it down to 44 feet in 1 second. So that car is traveling 44 feet in a second. So let's recap. Our first step was to understand what the problem was. The problem was we had so many things to convert. So I listed out my information. That way I'm organized, I know exactly what I'm going to be doing, and I can set that up into my plan to multiply each conversion. There's 3 of them. So I'm going to multiply them one at a time, separately. I started by reducing my ratio. You don't have to do that, but if you reduce your ratio, you end up with smaller numbers, and those numbers are a lot easier to multiply. I converted my miles to feet by setting up my first ratio to the conversion factor and just multiplied. Then I converted the hours to minutes, so I set up the latest ratio to the other conversion factor. Got 158,400 feet in 60 minutes. Then I converted the minutes to seconds, set up the latest ratio to the other conversion factor. 158,400 feet in 3,600 seconds. Then I just divided it out. That way I could get my unit rate, 44 feet per second. So a lot of steps, a lot of work, but as long as you have this plan to do it separately and you're organized, you're fine. So now I want you to try it. The train traveled 180 miles on a railroad track in 4 hours. How many feet per second was the train traveling? So, I want you to understand the problem first. So, list out your stuff, make your plan, make sure you reduce down to the unit rate, and go ahead and pause the video and please give it a try. You can press play and fix your mistakes, but I want you to try it first, so hit pause. Okay, hopefully you started by understanding that the problem was it was stated in units of miles and hours, and the question wanted in feet and seconds. So you listed out the important information, which came from your formula chart. Your plan was to multiply each conversion factor separately. So here's the process. First, you converted into a unit rate. That way you end up with a smaller number. You used that number and multiplied it by the conversion factor to get to feet, which was your first conversion factor. You used that latest ratio to multiply by the hours and minute conversion factor. Then you used the latest ratio to multiply the minutes to seconds conversion factor, and you got a pretty big feet to seconds. So you had to find the unit rate. You divided out, and I hope you ended up with 66 feet in 1 second. So the train was traveling 66 feet per second. This is how you use dimension analysis, your conversion factors, higher rigor with the multiple steps. As long as you're organized, you're able to do it.